So on the left here, I've got a histogram. That's one that we've seen earlier. And on the right, I've got a variation on that histogram called a frequency polygon. Now, the two represent the same data, but where the histogram uses bars that span the entire width of each class, the frequency polygon has individual points located at the midpoint of each class, and then they're connected to form a solid line. Now, in practical terms, any data that could be represented in a bar chart could also be displayed in this format. However, in my experience, bar charts are generally going to be the preferred format in the business world, where these frequency polygons are usually just called line graphs, right? And that's why I put frequency polygon in parentheses here. It's a technical statistics term that you probably won't hear so much in other settings. Now, in situations where you have two variables being measured, for example, grades and study time, a scatter plot gives you a way to look for a relationship between the two. So by putting one variable on each axis, then treating the paired results as ordered pairs, we get a graph like this one called a scatter plot. And when you plot the variables against each other, like I have here, you can visually see that there appears to be a linear relationship between the two. When the study time goes up, the grades also go up. Now, we'll talk more about numerically determining if there really is a relationship and then finding the actual equation of the line that best describes the relationship later on in the course. All right, so this ends our discussion of visual methods of summarizing data. For the remainder of this chapter, we're going to kind of look in the other direction and think about numeric ways of summarizing data.